Welcome to this deep dive into Objective 5, Security Fundamentals for the CCNA 200-301 version 1.1. In the world of networking, connectivity is nothing without protection. As a network engineer, your job isn't just to move data, but to ensure that data remains confidential, available, and untampered with. This section accounts for 15% of your exam, making it a critical pillar of your certification journey. We will break down how to identify risks, the human and physical elements of a security program, and the technical steps to lock down your Cisco devices. Here is the detailed breakdown for your video script. 5.1. Key security concepts. To protect a network, you must first understand the who, what, and how of digital threats. Think of your network like a house you are trying to secure. Vulnerability. This is a weakness in your system. It could be a bug in software, an unpatched operating system, or even a door left unlocked by a user. Threat. This is a potential danger that might exploit a vulnerability. A threat could be a hacker, a piece of malware, or even a natural disaster. Exploit. This is the actual mechanism or weapon used to take advantage of a vulnerability. If a vulnerability is a hole in a fence, the exploit is the person crawling through it. Mitigation techniques. These are the actions we take to reduce risk. This includes installing firewalls, patching software, and using encryption to make stolen data unreadable. 5.2. Security Program Elements. Security isn't just about software, it's about people and physical space. A robust security program relies on three main pillars. User awareness. This is the first line of defense. It involves teaching users how to spot suspicious emails or phishing links. A well-informed user is less likely to accidentally let a threat into the network. Training. While awareness is general, training is specific. This ensures that IT staff and employees know the exact procedures for handling sensitive data and reporting security incidents. Physical access control. Digital security is useless if someone can walk into your server room and pull the plug. This includes locks, security cameras, badge readers, and man-traps to ensure only authorized personnel reach the hardware. 5.3. Device access control, local passwords. In Cisco networking, we start by securing the front door of the device itself. Configuring local passwords ensures that anyone trying to access the command line interface, CLI, must prove who they are. There are three primary ways to set this up. Console password secures physical access via the console port. VTY passwords secures remote access via Telnet or SSH. Enable secret secures privileged exec mode. This is the most important password because it allows a user to change configurations. Pro tip: always use the command service password encryption to ensure passwords aren't visible in plain text when someone looks at your configuration file. 5.4. Security Password Policy Elements. A password is only as good as the policy governing it. Modern security requires more than just a simple string of characters. Management and complexity. Complexity. Passwords should use a mix of uppercase letters, lowercase letters, numbers, and symbols. Management. Policies should enforce password expiration, forcing changes regularly, and prevent password reuse, using the same password over and over. Password alternatives. Since passwords can be stolen or guessed, we often use stronger alternatives. Multi-factor authentication, MFA. This requires something you know, a password, plus something you have, a code on your phone or a hardware key. Certificates, digital IDs installed on a device that prove its identity automatically, often used for secure VPN connections. Biometrics, using physical characteristics, such as fingerprints or facial recognition, to grant access. Continuing with our deep dive into Objective 5, Security Fundamentals, we move from basic device access into the more advanced methods of securing data in transit and protecting the local network infrastructure. These topics cover the final segments of the security syllabus for CCNA 200-301. 5.5. IPsec Remote Access and Site-to-Site VPNs. A virtual private network, or VPN, creates a secure, tunnel over the untrusted internet. IPsec is the suite of protocols used to encrypt this tunnel. Site-to-site VPN connects two fixed locations, like a branch office to a head office. The routers at each end handle the encryption, so the individual users don't even know a VPN is active. Remote Access VPN connects individual users to the office from anywhere. This usually requires software on the user's laptop or phone to initiate the secure connection. 5.6 Access Control Lists ACLs. ACLs are the network's security guard. They are a list of rules that tell a router which packets to allow and which to drop based on specific criteria. Standard ACLs only look at the source IP address. They are simple but less precise. Extended ACLs, much more powerful. They can filter based on source and destination IP, as well as protocol, like TCP or UDP, and port numbers, like web traffic or email. Verification. We use the command show access list to see if our rules are catching the right traffic. 5.7 Layer 2 Security Features. Hackers often attack the lower levels of a network. We use these three features to lock down our switches. DHCP Snooping prevents a rogue DHCP server from handing out wrong IP addresses. The switch only allows DHCP responses from trusted ports. Dynamic ARP inspection (AI) prevents man-in-the-middle attacks. It checks every ARP packet to ensure hackers aren't trying to steal someone else's digital identity. Port security limits which devices can plug into a specific switch port. You can tell a port to only allow one specific MAC address. If a different laptop plugs in, the port shuts down automatically. 5.8 AAA Concepts. AAA stands for Authentication, Authorization, and Accounting. It is the gold standard for managing network access. Authentication, who are you? The login process. Authorization, what are you allowed to do? Giving a junior admin limited rights while a senior admin gets full control. Accounting, what did you do? Keeping a log of every command the user typed. 5.9 Wireless Security Protocols. Wireless signals travel through walls, so they must be encrypted. There are three main versions. WPA, the original, now considered weak and outdated. WPA2, the current standard. It uses AES encryption, which is very strong. Most networks today use WPA2. WPA3, the newest version. It provides even better protection against password guessing attacks and is required for the latest Wi-Fi standards. 5.10 Configure WLAN with WPA2 PSK. In the CCNA exam, you need to know how to set up a basic wireless network using a graphical user interface (GUI), usually on a wireless LAN controller (WLC). WPA2 PSK, pre-shared key. This is the home Wi-Fi style where everyone uses the same password to join the network. Steps. In the GUI, you create a new WLAN, give it an SSID, the name people see, enable WPA2 security, and define the pre-shared key. Verification. You check the WLAN's summary page to ensure the status is enabled and the security settings match your requirements.